resistance like R1 and R2 and R3 there. So you have to remember one important thing. There is a one thing constant throughout. What is that constant thing?
Current.
The current, amount of current is constant throughout, right? The amount of current is very constant throughout, right? So going to multiply I, and I always constant throughout. Okay. Now we know one thing, the voltage divides according to the magnitude of the resistance, because why? According to V equals to IR, as the R component increase, the voltage also increase. So the voltage divides according to the magnitude of the resistance. So we can take it like V1 and V2 and V3 across. So what is my final result that I'm going to get is this one has resistance R, the R equivalent resistance REQ, and the same current flow across it I, and voltage is V, right? So there is a one thing, this split of voltage should be equals to the sum of the voltages. So you can write it like V equals to V1 plus V2 plus V3 as the equation number 1, and can substitute this X factor equation X into equation number 1. After the X factor, sorry. IR equals to I same the R1 plus I R2 plus I R3. Okay, so I and I cancel. So finally you get the equation of what? R equivalent equals R1 plus R2 plus R3. Do you need me to explain that again?
Let's go case one.
Okay, do you need me to explain that again? No, can you understand by this explanation only?
Can understand.
So voltage splits in series and
Yeah, voltage split in series and the same current flow across, and voltage split according to the magnitude of the resistance. If the magnitude of the resistance is really high, that voltage is also going to be really high. You have to know this one for the voltage divider stuff as well.
okay.
Okay, got the point? You need me to copy this down? Shall I move to the parallel stuff as well?
I don't
Uh,
need anything.
Do you need to copy this? So
Gave this to me. You gave this to me already, no? I
yeah,
have
yeah,
stuff.
I have this already. And the next thing is the parallel
Can you
connection.
zoom out for a second?
Zoom
The
out.
hetu denawada?
Huh?
Hetu denawa?
Eno.
Okay.
Then Jason, it's like 11:30. No?
මට අද ඉන්න දන්නේ but
Moka? Indian?
yeah, I just slept from 4 to 9.
Fuck.
No, I want to go to sleep at 9.
Oh shit. Because of the high humidity in the evening time, we feel like sleeping a lot. So in the parallel connection, it splits what? Current is the one going to split. The voltage is always but constant throughout, you consider these 2 points like P and Q, across PQ, VPQ is always constant. So this one is also joined to PQ. This resistor is also joined to the PQ axis. See, PQ. This one is also across PQ. This one is also across PQ. So it's a common junction. So the voltage is going to be the same throughout these 3 resistors. Now the equivalent resistor is as same as of the previous one. And voltage V and current I. Okay. What can I do now? According to here, it's not the voltage split here now, it's the current. I equals to I1 plus I2 plus I3 as the equation number 2 here. And from Ohm's law, V equals to IR. What do I need to get here is I equals to V over R as the equation number Y. I'm going to substitute the equation Y into equation number 2 here. What can I get now? The same voltage over R EQ plus same voltage R1 plus voltage over R2 plus same voltage over R3. Now it's going to cancel out each of these terms of V out of the equation. 1 over R2 equals 1 over R1 plus 1 over R2 plus 1 over R3. Do I have to explain that again?
Shape, that's it.
Okay, if you want, take a screenshot or something, because even I'm going to share you the what is it called, PDF even.
I took.
I might just get kicked out of the meeting. Can you hear me?
Yeah.
Yes, sir. Let me move on to the new part. This one is already explained now. Are we supposed to do these 1 or 2 of these silly calculations? So move on to the next one.
So directly
just
can
what-
do potential divide.
Directly to potential divider without doing any of these.
Yeah, yeah.
Yeah.
So after that, can we do electricity questions from past papers? I have the book. I can.
Yeah.
Yeah, let's do the
Electricity.
electricity questions from the past papers.
Okay.
So, but before that, rheostat also and potentiometer, those things.
Okay. Are you familiar with this electric circuit rule? That means it's like the Kirchhoff rules.
They haven't taught that in school yet, so they are not teaching it as Kirchhoff's rule, by the way.
What?
We learned it. No?
They are not saying Kirchhoff's. I don't know. My teacher, she is not saying it's Kirchhoff's rule.
No,
But she
they
said
say
we
like
don't.
voltage rule and the current rule.
Yeah. I think something like that. She says they don't refer to this.
Yeah, they say it like current rule and the voltage rule. So somebody used to say like Kirchhoff rule number 1 and Kirchhoff rule number 2. That depends on with the teacher.
We didn't do number 1. I think number 2. I think I'm not too sure if she did that. I don't think our class hasn't done that properly. You know?
Okay, somehow. Do you need me to do this one or skip this?
Shall we just do it?
Give me a idea.
Okay.
Nothing is that.
So,
Do or not?
we'll do.
Will do. Yes, I also don't understand properly. Okay, I'll explain it using a different diagram. This one is a real sheet. Okay. in a certain circuit, there might be this type of junctions. And it's like I1 and I2 and I3 carry the current away, and I4 just the same way. And there might be another I5, it also brings the current towards the junction. This is the junction X. Okay. How about the total current? So it says the sigma, that means the sum of the current is always equals to 0 at a junction. Yes. That's what Kirchhoff's rule number 1 or the current rule. Okay.
Yeah.
Okay, can you understand? Kirchhoff's rule number
Yeah.
1 or the current rule. Okay, guys?
Yeah.
Yes, sir.
So what can I say about like that? I1 plus I2 plus I5 minus I4 minus, sorry, I3 equals to 0. Or you can write it like this way. How? I1 plus I2 plus I5 equals to I3 plus I4. Whatever the way you would like, you can express Kirchhoff's rule number 1 or current rule in a junction. That is what it explains here. See, any of these junctions. What is the total current here? 0.8. And across this loop, there is a 0.4. What should be this one then? Should also be 0.4. That means 0.8 minus 0.4 is 0.4 remaining. And the total again joins up together, likes of 0.8. Understand?
Yeah.
Okay. Now the second rule or the voltage rule, that's the most important one. And that's the one mostly everybody kind of wind up with each other stuff. I'll just firstly start off with the simple one.
This is what voltage rule.
Yeah, this is what called the voltage rule. So this one is the EMF supply epsilon, and there is a resistance of R1 and R2. As I told you in earlier, so the supply voltage or the EMF should be equals to the potential drops around each circuit. This is V1 and this drop is V2. I can represent it like so what current is I throughout the circuit. I. So what can I say? According to the voltage rule, that means the supply, that means the EMF should be equals to the potential drops. So that means V1 and the other one is V2. As we know, another thing, V equals to IR from Ohm's law.
So you are taking components or resistors?
Huh?
These are resistors at R1 and R2, no?
Yeah, R1 and R2 are resistors.
So if there's a component, do you consider that's internal resistance thing also?
Yeah, no, that's why I told you. I'm just getting a simple example for the
Okay.
first one. In the second one is going to be really complicated one. And a third one, if you need, even very complicated. Epsilon, I have nothing to change here. What is it? I R1 plus this one is going to be I R2. This is one of the representation that I can get. Can you understand all of these things?
Yeah.
Okay, good. Now I want to go for something bigger. So here it is not one single power supply. R2, and R3 in capital letters. And there are certain other R's like R1 and R2. Simple R1, simple R2, and the epsilon 1, and in here, epsilon 2. That means the EMF of the cells. Okay?
Yeah.
The same thing, what? Here there is, I will start this point as A. I will mark this point as A, and this junction as what? B. This one as C, this one as D, and this point as E, and this point as F, and again A. So the direction of my positive direction is clockwise. So according to this clockwise direction along what? The loop of what? A, B, C, D, E, F. Again finishes at A because it's a loop. Loop means you have to start from here and you have to finish also at the same point. That's how the loop when we concern about the loop. So this is like the V1, and here the voltage is V2, and don't forget that there is a potential drop around one. This one as well, because there is an internal resistance. I can consider this one as a drop of what? V3. Can you understand this point, this particular point?
Yeah.
Is there anybody who doesn't understand? So there is a potential drop, all because of why? Internal resistance, and the other one is V4. And there is another drop here. What is that drop? V5. Okay. What can I write about? So what are the supply? This one is a supply. This one is also a supply. But this thing and this thing now, but face-to-face connection. That means this one, the other one facing the opposite direction, because this one carries the current potential in the right hand side, and the other one brings the current to the left hand side. So have to mention about that one too. So my equation is going to be epsilon 1 minus epsilon 2. That's going to be equals to what? V1 plus, V2 plus, V3 plus, V4 plus, V5. Can you understand?
You said epsilon 1 minus epsilon 2 because it's in
Yeah, they
opposite
are just
direction.
varying the current in the opposite direction. This one to the clockwise direction, and the other one is to the anti-clockwise, facing each other in the opposite way. Right?
Then how did you just take V1 plus V2 plus V3?
Because potential drops. This one drop according to R1. There is a potential drop according to the R2. There is a potential drop according to what? Simple R2. There is a potential drop according to capital R3, and there is another potential drop according to simple R1 of the cell.
Yeah.
Okay, what is it going to be the V1? The current is I throughout the circuit. Current is I all throughout the circuit. So what is it going to be? E1 minus Z2 equals to I R1 plus I R2 plus 1. Here it's also potential drop. I simple R2 plus I what? Capital R3 plus I simple R1. Can you understand this?
Yeah.
Okay, this is all about Kirchhoff rule of the voltage rule. I explained you even a bit harder one than this one. So if you understand mine, so this voltage rule is going to be nothing. See? In the book, it's a very simple one. Can you just understand this one, or do I have to explain that again?
Understand.
Everybody?
Yeah.
Yes, sir.
Then shall we some questions from this one before going further? other rule like here, this one is a very simple one. Okay, let's finish the potential divider too, no? Right? Let's finish the potential divider as well, and the other one, the potentiometer or rheostat, those silly stuff.
So
And
with the potentiometer, you can drop the current to 0 or something, right?
yeah,
But
drop the current
Oh,
zero.
yeah,
but
when
you-
you go certain distance, say it dropped to like -1. No, Ramasisha?
Yeah, because the infinite of the resistance. When the resistance is
the what
really
is
high, the
resistance?
current reach to 0.
But rheostat can't do that, no?
Yeah. Okay. The meaning. Wait for these ones like R1 and R2, while the external voltage supply of E, they are epsilon actually. The current is I throughout. Then there is a resistance of R1 and R2. And as I told you, the voltage is split according to the magnitude of what? Magnitude of
Magnitude of resistance.
resistance according to Ohm's law, right? So we know one thing, the current is equal throughout. According to V equals to IR, you can get I equals to V1, just V over R as the X factor. So at this point, I can write like I equals to V1 over R1, is the number 1. And this part, the same I equals to V2 over R2. And the equation number 2, this is going to be, let me merge this. And equation number 1 equals to equation number 2 because it shares the same current. V1 over R1 equals to V2 over R2, or we can just rearrange the equation in this manner. How? Sorry. So in another simplified version, V1 is to V2 equals to R1 is to what? R2. Can you just understand this? Or am I supposed to read that again?
Sir, can.
What?
Yes, sir. Make it.
Sir, I'll take a screenshot.
Yeah.
Okay, good.
So that Tamil dude has forgotten. I called him.
He
So
forgot.
that Tamil dude is retarded. He won't
Yeah.
come for classes actually. What about that
That's
track?
the thing, you know. I have CS kar.
Tisar, he's calling me and shouting, why is Tisar calling me? He came.
Hello, Dilupsan. Where were you? Were you sleeping?
No, sir, I didn't see the group message. My
Ah,
phone wasn't there. I didn't open WhatsApp.
okay. Now, we were talking about potential divider thingy. I will just explain this simple potential divider quickly. What is potential divider thingy here? That's the epsilon equals to what? I, and R1, R2 is the resistance here, and current is equal throughout, and the voltage is split according to the magnitude of the resistance. See? R1 and voltage 2 according to the magnitude of R2. We have to know one thing. I current always equals to what? Voltage over current. So here according to this X factor, what is the current across this one? V1 over R1. What is the current across this one? That's V2 over R2. According to this current rule, right? We know that the current is going to be constant throughout. So equation number 1 equals to equation number 2. So V1 over R1 equals to V2 over R2, and can rearrange by splitting, sharing these two. And it's like V1 over V2 equals to R1 over R2. So we can also write this in some another method. V1 is to V2 equals to R1 is to R2. Can you just understand that?
Yeah.
Okay, good. But this is what most people really see it overwhelming for them. Actually, really easy. Okay. Let me use your convenient symbol like a box. I'll use a different symbol, call it like VI in input voltage, and there is a resistance of R1, R2, and how about the current throughout the circuit? That going to split
Grounds.
the same. It's going to be the same current. Right.
Same current.
I'm going to drag some current out of these two terminals. I'll make these terminals like P and Q. Across these 2 points of P and Q across the resistance of R2. And that's going to be my output voltage. So I mark it like V out. Got the point?
So you are connecting voltmeter there, right?
Yeah, you can connect a voltmeter and measure that. Right? So how to get this voltage? We know one thing. I can apply what? Applying
Resistors in series.
V equals to IR across what? Across PQ. Right? PQ junction. So what can I write? V out equals to what? I R2. Equation number 1. Can you understand that?
Yeah.
Okay, we have to find out somehow what is this I. I know that this is R2. How to find out I? According to what is it called? Kirchhoff's rule or whatever the rule, I can take it like again applying V equals to IR. What is this R? R equals to R1 plus R2. Why? Because
Total resistance.
these two are in series. Because why?
Series.
In series connection. Right. What can I write now here? V out, sorry, the total voltage V in equals I R1 plus R2. And I can rearrange this equation and obtain but I equals to V in over R1 plus R2 as the equation number 2. Got the point?
So V in means the voltage for the entire circuit, right?
Yeah, input.
Okay.
Input. This one is output. Okay. Now I'm going to fit equation number 2 into equation number 1. So it's going to be V out equals to the I from here, V in over R1 plus R2 times R2. This looks really ugly. Right? This looks really ugly. So I rearrange in this manner. How? V out equals to R2 over R1 plus R2 times V in as the finalized equation. If you want to, you can write or just understand whatever you need.
So 1 meter, right? Okay.
Okay.
So there's an equation of V out equals V in.
Yeah, what? What did you say? There is an equation V out. What?
Divided by the total resistance multiplied by the voltage. It's a, you are basically taking as a total resistance.
Yeah.
That's what you're finding. Matisha, can you scan and send Nirmalan unit and all the book tests to sir?
Nirmal's what book? You told me about something like a booklet you found something, huh? Okay. Okay. A circuit set up as shown in the diagram, the battery has a negligible internal resistance. That means you don't want to consider about the and 9-volt supply and 80 and 40. Right? Calculate the potential across this one. It's like V out now. It's as same as of what the previous
Okay,
potential divided. Isn't that? V40 equals to what? R40 over R40 plus R80 times what? V. So what is the R40 over 40 plus 80 times V in is 9-volt. So let's try like 40 over 120 and 9, 0, and 4 gone, and 3 gone, and 4 and 4 cancel off. Is 3-volt. Don't worry about my working method. It's like a manual method. So use your calculator. Did you get this answer? 3-volt across 40 ohm resistor. Guys, am I audible to you? Okay.
Yeah, it's a Heshika joke.
Okay, did you get this answer,
How
guys?
much did you get? How much did you get
I
for
thought-
V2H?
By the way, guys, did you get this value? 3-volt.
Yeah.
Okay, now there is the thermistor connected in parallel with 40 ohm resistor as shown. Okay, now thermistor. What is the value? The thermistor is initially at temperature of 100 degrees Celsius and the resistance is at 20 ohm. Right, it's 20 ohm.
Can you substitute that?
So now this setup you have to draw it again like in the previous. Now with R equivalent. Right? Hey. Am I audible to you?
Yeah.
Yeah.
Okay, R equivalent is 80. So what is the equivalent resistor? 140.
40 plus 1 or 20.
1
And then your
over-
reciprocal.
Yeah, 20.
Is 40 over 3.
40 over 3.
The final answer is 40 over 3. Yeah.
That is 40 over 3 ohm. Now you have to substitute this to there. and find out the what is it as
Total
the
resistance.
as the thermistor cool down, its resistance increases, right? Okay. So explain what happens to the current through the battery as the temperature of the thermistor decreases. That means cools down. That means the thermistor decreases, the resistance increases. When the resistance increases, what happens? The equivalent resistor also going to increase. Huh? Equivalent resistor increases. As the equivalent resistance increase, how about the voltage? Voltage across these two
Rises.
rises. Actually, you don't
Because
want
current
any
is
calculation,
constant.
right? They don't ask any calculation here. Just to explain the equivalent resistor, you have to show like at the initially equivalent resistor is like 40/3. So the equivalent resistor keep increasing as the temperature drops and the resistance increase. So the voltage across what equivalent resistance also increases as well. Okay. That's
Okay, so
Okay.
the voltage increases. What happens to the current?
Current is constant.
current is current also increase. So current decrease. Current decrease.
Wait,
Current,
current decrease.
yeah, current decrease means
Because resistance isn't constant here, Matish. Resistance is the one that's changing.
the resistance in this part increase means what about this overall resistance? That resistance
Increases.
also increase because these two are in series connection.
Yeah, then
Yeah.
I is the input voltage divided by the total
Equals to
resistance. So the total
IR.
resistance.
How about when the resistance increase for some fixed voltage supply, current decrease? You have to mention like according to Ohm's law for a fixed supply voltage, current drops as the resistance increase. You have to include these terms, otherwise you get no mark. I have to give you a big training on how to write the answers even, because you might write the correct answer, but you might not get good marks. Because why?
Yeah, sir. In the physics test, there was a question in the ultrasound part why the wave has to be sent in pulses instead of continuous. I said so you can recognize the like the reflected wave and it's easy to distinguish it because if it's continuous you can't. But that wasn't in that mark scheme and that Mr. PR didn't use a mark. He says one has to be received before you send the other, but that's I don't know.
That's why there is a gap.
But that's rewriting the question. Basically, the question is saying why you should send it like that, and you are saying one should be received before you send the other.
Yeah. That's what I'm telling you. There is a certain way of expressing your answer.
No, shouldn't you be explaining why it is like that instead of just writing the same shit? It's so annoying.
Yeah. It's odd. But if the question asked in that manner, what can you do? Okay. So now let me know one thing. Are we supposed to do the what? Internal resistance and EMF thing right now or in the next day? Today, shall we practice more questions or just keep doing this EMF thing even?
Can we do questions from past pair? I don't know. What do you all want?
No. Whatever you need, I just feel also like it's better to do some questions now. Rather than,
yeah, some questions from past papers or something. Anything.
Yeah. Will you send
So
some?
what do I do with the practical book? I have it. I don't know what to do with it.
Okay, I will tell you what to do tomorrow. That bugger got it, na? All the things. Okay. Hey, are you sending the paper?
I'll just find random electricity questions and check from the past paper.
Yes, about
I got wait. I got 3.125.
Yeah, somehow. If that is closer to 3, that means you got the answer.
No, I got stuck somewhere. I missed that part.
Okay.
Wait, sir, but we got different answers and approximately.
No. I didn't even add do. I don't know if I add do, I'll get 8.
Okay.
I don't know how.
How to do that, I will tell you how to deal with these type of questions.
Above
like,
that,
bro,
M is also there, no? There's another. Hari. පොඩ්ඩ ෆෝන් එක දෙන්න මට බන්ද.
I like I1 and this one is like I2. Split through here. Current I pass through it and the voltage of V. How can we get it right? We know one thing is common. What is going to split? I1 plus I2 is the splitting one. And I equals to V over R. And it's going to be like V over R equals to V over R1 plus V over R2. And we cancel off 1 over R equals 1 over
Yeah. 3.125, Matish. I got it.
Okay, this is how you derive. Derivations are really important to remember. Okay, now the next one. Okay, have a really good look at. Firstly, you have to remove these two, right?
Yeah.
So
You add
use your up papers. Use your up papers to do that. That's why they spare some empty papers. So here, what is this? 10. So what is this part now? This looks really simple now because this one is a one resistor now, and this one, and this one. So now 10 and 5. How to deal these two with what? Now these two are series and these two are parallel. In the parallel connection sense, 1 over R equals to 1 over 10 plus 1 over 5. So what is it? 10 over 3, isn't that? For this part?
Yeah.
Whole thing is 10 over 3. Now you have this one together. And here there is a one like 10 over 3 and 5. Okay. 5 and 5. So I have to find out this one as a 1 resistor now. Above is 5. The bottom is going to be something we don't know. What is it? Now 10 over 3 plus 5. Sorry, so direct addition. R equals 10 over 3 plus 5. So it's going to be like 15, 10 like 25 over. 3 is the answer for this one. 25 over. 3 is the answer for this one now. Now get the R equivalent. Now these two are parallel. Now how to get it? 1 over 5 plus 1 over 25 over 3. The common denominator is become 25 now.
8 or 25 comes.
Yeah.
I think.
So like 8, 25. So R equals
25
5 over 8. So when you get it
3.125.
like 0.125, no?
Yeah.
So this is approximately equals to 3 ohm. So a really simple question, nothing to worry about, but only you have to split the same resistor again and again slowly. That's the technique to apply to here, because mostly you get bewildered when you see this. Don't be panic, just use it like how? One by one. So unwind the question like one by one. So there's nothing to harm you. Now the next one, do it like within 5 minutes. Start.
So